Here's the last one, and that's interfaces. Interfaces are different in that a subclass can actually implement many interfaces. And I'll have to show you that in a minute, so bear with me on this one. But everything in an interface is completely abstract, which you and I have talked about. Data methods are in there. Here we are able to get away with setting some values in this compared to an abstract class. Here we're able to set some variables in here because I'm going to use them as an interface, meaning I'm going to be able to pull the word like new from this interface and it knows it's going to be 1. That's my interface portion of this. Now, you're also going to notice from the interface class here that there's my abstract methods. Methods are treated as abstracts. The variables, they give you a little bit more wiggle room in an interface. Notice I'm able to set a perfectly good string to new in this case, which, by the way, isn't used in the example. I'm not sure why. But anyway, the functions themselves, the abstract methods, they are abstract like you normally. Notice they're not set. They have to be set by whoever is going to interface with this particular class. By the way, interface is highlighted, and it's a keyword. The name of the class that is the interface usually has the bool behind of it, kind of like, more like convention to kind of let you know that it is an interface type of thing. And I'm going to show you how that's integrated here in a second here as we move down to our public class car that implements actionable. And by the way, I could have comma, another implementing class, another one. It's kind of it's almost like inheriting because it's pulling some other items in there. Because here I am using here's their get description to tell me exactly what. And notice I had to spell these out. These were abstracts. I had to cover that. That's the contract using an abstract. I then have to cover it by whoever's implementing it or inheriting it from that spot. Here I make my other setups here. The like new, notice that pulled right from the like new that we were implementing. It's going to know what it is because it implements it. So notice it's inheriting some items from that interface that we can use later on. Notice, by the way, this is meant to be short, sweet, and to the point. This is not meant to have a lot of items in it. It's not like an abstract class that could have had constructors, could have had more meaningful functions, really definitions, some other items that were in it. This is meant to be short, sweet, and to the point. That's really what an interface is compared to an abstract class. The abstract class is just meant to be larger and more defining, setting up standards. The interface is really just trying to make things simpler on you in the long run. So that is one of the big differences between the two, is noticing how much shorter really the interface is. Like it said in the original setup for the title, this is an exercise. I want you to go through this thinking about, well, the questions that we have, and send me your results. I'm curious in seeing what we get from this. Let's put it that way. Notice I'm trying to keep with the base class of shape. Then we have rectangle, circle, and equatorial triangle. I'll have to check to see if that word's right. But anyway, we'll go from there. Remember again that we're talking about setting up some things that are going to be, I think there's some abstract in here. Yep, abstract or implements model. So here's the neat part. You can get away with this one because it's not super big of doing one or the other. I'm curious on what you're going to do. So get this done, try things out. If you don't get it to work the way you want, let us know and we'll help you out with that. But we have a couple more things here first I want you to finish, and then after that, come back to this.